Hey kids, this is Mr. Cozy. This is video number 14, and we are talking about set theory. We'll talk about the definition of a set membership, set equality, and set containment. So let's get started. The funny thing about defining a set is that there's actually no logically consistent mathematical definition of a set. Mathematicians and logicians struggled with this concept in the early half of the 20th century, and eventually concluded that it couldn't be done. So instead, they came up with a set of rules or axioms that limited what they could do with sets, but it at least guaranteed that everything that they did was logically consistent. And this is something that happens a lot in math, as in real life. Just because something is kind of broken, it doesn't mean that it is worthless. And sets are extremely useful, extremely valuable, and so we use them and put up with the fact that there's some logical inconsistency behind them. This is all really theoretical. You are waiting for me to give you the definition of a set. So a set is a collection of things. And for our purposes, those things will be numbers. So an example of a set is the number 5, 8, 10, and 13. And I enclose the set in curly braces. Okay? Now, every single one of these numbers is called a member of the set. So if it's in the set, it is a member of the set. Once again, if it is in the set, it is a member of the set. Here's another set. 7 for negative 8.1 and 1. There's another set. Now you're probably wondering where I am getting these numbers, and to be honest, I'm just kind of making them up, because a set is any collection of things. Now, though that collection could represent something, or it could just be a random collection. This is an example of two sets that are just random collections. Here's a set that's actually something. 0, 2, negative 2, then 4, negative 4, 6, negative 6, 8, negative 8, and on forever. You may be guessing that this set represents all even numbers. Now, funny story, a set is any collection of things. So an interval is a collection of numbers. It is a set. This interval is the set of all numbers from 1 up to, but not including 5. Okay? So these are all sets. Now, I could just list the sets out like this, or I could name them. Let's call this set A. Why A? Because I just named it. I picked a letter and said that's set A. We typically use capital letters for sets. We use lowercase letters for individual members of a set. We use capital letters for sets. B. Let's call this B. Let's call this E, since it's all even numbers. And let's call this I because it's an interval. Okay? Now, something is a member of a set if it's in the set. Okay, so this 8 is a member of set A. Okay? I can write that out this way for membership. I can say that 8 is in A, and this little e looking thing, it's actually written like make a little C and then put a cross in it. Okay, 8 is in A. 7 is in B. Okay. Now this this E looking thing, you draw it very carefully. It's like a C but with a little prong in the middle. Okay, and this is saying that 7 is in B. Pick any number, any even number. I'm going to pick -6. Pick any even number and write out that number is in E. Okay? It's a member if it's in the set. So make a C and cross it. And that says that's short for is a member of. Okay? Now, if something is not a member of a set, I write that E and then cross it out. Okay, so for instance, 7 is not an even number. So 7 is not in E. Okay? If it's in the set, it's a member and I write the E. If it's not in the set, it's not a member and I write the E and cross it out. Choose any number you want. I'm going to choose pi because that's a number. Pi is not in, is not in B. There we go. Okay, so if it's a member, if it's in the set, I write that E looking thing. If it's not in the set, I write an E and cross it out. Okay? So here's a question. Remember that I was this interval. Is 3 in that interval? Is it in there or not? So of all of the numbers from 1 to up to, yet not including the 5, is 3 one of them? And the answer is yes. How about 5? Is 5 in the interval I? Remember that this we named I. Is that true? No, because this is a parenthesis. The 5 is not included in the interval. Cross it out. Okay? So, to show membership, I write an E if it's in the set. I make an E and cross it out if it's not. Two sets are equal. Set equality. Two sets are equal if they have the same members. And it's got to be exactly the same. Order doesn't matter. Okay, so let's think about this set 1, 3, and 5. And let's look at the set 5, 1, and 3. Do these two sets have the same members? If they do, they are equal. And these are. If one set has different members, and it's just got to have one member that is different, or one member that the other doesn't have, then the sets are not equal. Okay, so for equality, the sets have to have the same members. Okay. All right. I'm short on time, so I'm going to talk about containment tomorrow. We will practice a little bit and call it a day. So yeah, I will talk to you guys later. Have a great evening. Bye.